I'm going to introduce Newton's method, which is a way to approximate solutions of a function. So let's say you have some polynomial here, and I'm just saying it really cryptically at this point, but I am going to show you a nice example about using this to figure out square root of 3 and square root of 2, okay? So imagine that you have some polynomial or some kind of function here and you want to know where the 0 is located. What you want to do is you want to take an initial guess, and Newton realized that if you take the tangent line and look at its x-intercept, then the x-intercept becomes a much better guess to the actual thing, right? So you're improving your approximated guesses. Okay? So then you can do this again, and you can, if you run it again, then you get an even closer solution. And you do this for many times, you can figure out the answer. So that's the idea of the Newton's method. Okay, so I first want to show you the formula for this, and I will apply that formula to the square root problem. Okay? So let's say we have in general, we'll call this function y equals to f of x. So if x coordinate is a, what's the y coordinate? F of x, right? What's the slope of this line? Slope is given by? Slope of the tangent line is given by? F prime, right? So you have to evaluate at a. So we know that the slope is f prime of a. Now let's apply the point slope form. You know this formula, right? And the slope is f prime of a. X1 is, well, x1 and y1 are the point on this line. So I'm going to use this one for x1 and fa for y1. So I'm going to put a here, and then I'll put y minus y1 is f of a. And as I said, I want the x-intercept of this. How do you find x-intercepts? Set y equal to 0, yes. You set y equals to 0, and now we will solve this for x. It's divided by f prime of a. And now you add a both sides, and you get x equals to a minus f of a divided by f prime of a. And this formula here is the way you improve your guess. Okay? If you had an initial guess, then applying this formula will give you another number, which is a better approximation to what you want. Okay, now let's see how we can use this to figure out some other things. So I realized that yesterday when I was doing square root of 3, a lot of you didn't know the approximate value for square root of 3, right? So let's try to find the value of square root of 3, an approximate value of square root of 3, by making use of this. And the beauty of this is that you can find this value even without a calculator. Okay? So let's try this. So first, the idea is to call this x. Square both sides, what do you get? 3 equals to x squared, right? Subtract 3, so you get x squared minus 3 must equal to 0. Oh, that's exactly the type of question that Newton's method can solve, right? Because we have x squared, which is the problem, and you're subtracting by 3, so it goes down by 3, right? And we're trying to find out where it meets the x-axis. So that's exactly the kind of question we have. Therefore, we just have to come up with an estimation, and it will become better. Now, while I could already just use this formula, I'm going to make this formula a little bit easier to solve by doing some more calculation beforehand. So this is going to be our f of x. What's f prime of x then? What's f prime of x?
2x.
2x, right? It's just 2x. So you have a minus f of a. What's f of a? If this is f of x, f of a is a squared minus 3. And then what's f prime of a? 2a, right? Okay, that's going to be the better approximation. I want to combine these two by making common denominators. So I want to multiply 2a top and bottom. 2a times a is 2a squared over 2a minus, well, I'll put plus and I'll distribute the minus to each one of them. So you have negative a squared plus 3 over 2a. And that gives you a squared plus 3 divided by 2a. Okay, you might feel that this is simple enough, but I will do one more step. And it turns out that although the form looks ugly, it's actually easier to do. So what I want to do is I want to divide top and bottom by a. So a squared divided by a would be a. 3 divided by a, well, it is 3 divided by a. Then 2a divided by a will cancel the a and you'll just get 2. Okay, so that's the formula that we will use to get an approximate value. Okay, so what's your initial guess? Square root of 3. Like, if you had no idea what square root of 3 is, what's like the first value you would try with? Like, I know that it's bigger than 1, right? 1 squared is 1, 2 squared is 4. So what do you choose?
1.7.
That was too close. I'll say we had no idea, so we just say 1.5 as our initial guess. Okay? Yeah. Because it's no fun. 1.7 is already too close. Okay, so let's start with 1.5. And then we're going to use that formula. Then our improved approximation will be like this. It will be 1.5 plus 2 divided by 1.5 divided by 2. Okay. While dividing by a decimal is not so pleasant thing to do, you can do the following. You can multiply by 2, top and bottom. Okay. Then this becomes 1.5 plus 4 divided by 3. Oh, sorry. That's 3, right? Sorry. Okay. So it's going to be 3 times 2. And then 3 and 3 cancels. So you get 1.5 plus 2 divided by 2. What's that? What's the average between 20 and 15? Or 200 and 150. If you earn $150 the first day, 200 the next day, what's your average daily income? 150 and 100, 200. Huh?
175.
175. So this is going to be 1.75. Okay, and then I claim that this is a much better approximation to square root of 3 than before. What should you do if you want to improve this even more? Plug it in again. Yeah, 1.75. So now, for the next better approximation, we're going to do x equals to 1.75 plus 3 divided by 1.75 over 2.
Should I wonder if like communism has lost all its meaning because everyone has gone through high school?
And this one, if you multiply 4 top and bottom, you'll see that this gives you 12 over 7. And I'll just save you some time. So if you do 12 divided by 7 and do some calculation, you get something like 1.71. Okay. Just taking 12 and dividing by 7 and doing this, you get this. It's not that hard. Okay, so you have 1 and 5. What's the average?
1.73.
1.73. Now, if you use your calculator and do the square root of 3, you're going to get 1.7320 something. Okay? So that's pretty neat. Okay? If you want even more decimals, you just plug this again and do it again. Okay? So that's the idea. Now, this method was actually invented just for the square roots many years before Newton. Can you guess when mankind first knew of such a method?
Back in
No, not 1500s, even before. Closer.
Romans?
Babylonians, 1500 BC. Yeah. So what they did was, this is actually called Babylonian method. So think about the following. If you have 3, 3 is square root of 3 squared, right? That's the definition of a square root of 3, right? So if you divide both sides by square root of 3, you have the following. You have 3 over square root of 3 equals the square root of 3. And that was the idea of Babylonians. The way you're doing this is, let's say 1.5 was really the square root of 3. Then 3 divided by 1.5 and 1.5 would have to be the same, right? Because of this property, right? However, it turns out that it was an underestimate, right? But if this is underestimate, this will be an overestimate of square root of 3. And the idea is simply, well, if one is underestimate and the other is overestimate, how do you get a better result? You just take the average of it. And the Babylonians, 1500 BC, used such a method. It's called Babylonian method, to find out the square root of 2 to 6 decimal places. Back then, when they didn't even have Arabian number system like we have, they had like cuneiforms and clays, and people looked at the digits and it was, oh, that's square root of 2. They had 6 digits correct. And the way they would do it would be to start with 1.5 as the square root of 2, and you do 2 divided by 1.5, and you divide by 2. Well, this is like 4 over 3, which is like 1.333. And if you take the average of these two, you already get something like 1.41. And if you do this a few more times, like maybe 3 or 4 more times, then you get 6-digit accuracy. So that's a very interesting history of